Hi everyone, welcome again to OpenVINO Workshop. So this DevCon workshop will be based on generative AI today. Aren't you excited? I'm excited. So we today have many of our engineers coming in to support the questions Q&A. We have Brian, we have Paula, Maria. So now go under here and click on the Q&A button and you can talk to any of them. And what's important to you is if you have any questions, you can also come to me at the end of this conference and ask any questions. Well, to get started right now, for all of you, there's also in this little icon says Hangout. So So what you need is you click on it, you can download the PDF files, all the slides here today. And if you have any follow-up questions, there's QR code you can scan to find us. Well, to no further ado, let's introduce the team to here and let's say hi to everybody in this room. Hi, Paula. Hi, Rear. Hi, Ryan.
Hey, Raymond.
All right. So, well, again, we have almost 100 people waiting here. So let's give a one-line introduction, what you're doing at Intel, so we know what to ask.
So let me start first. My name is Pablo Ramos. I am AI software evangelist. I have a PhD in computer vision. I'm so excited to share this with you today. And I hope that this could improve your journey as a developer.
Thank you.
I'll go next. Hey, everyone. I'm Ria Chervu. I am an AI software architect and AI evangelist at Intel Corporation and have a master's in data science. Really excited to be here and help with your questions.
And hi, I'm Ryan Loney. I'm a product manager at Intel for OpenVINO and really excited that you're all here today.
Great. Again, thanks everyone to be here. And then let's get started with our very first question today. If you haven't heard about it, well, most likely you have heard about ChatGPT and some capability that you see in the media today. Because generative AI has been really changing the way we've solved many problems. But what is it exactly and why as a developer and Intel care about it? I think in a short answer is think about the capability we had in the past with AI, right? We always trying to really make up a model, like put a lot of expert to solve, let's say, a problem like object detection. And during that process, oftentimes these are very hard to generalize. But today we have, let's say, LLM, which is large language model, and these created a fundamental that actually you can use to, create solutions based on something that, with a large data. And why is it important today to us is it's very hard to scale. There's a lot of the problems that we have to solve. And particularly, I think, let's look at why so many people are using it. Because today, if you look at gaming experiences, for example, Unity have released like a new example where you can generate a scene just by giving a prompt. And for room designer, for let's say artists, you can see a lot of stable diffusion, which is one of the techniques we use to generate graphics. And that's very exciting because very recently you can see Adobe have released some of the tools that using that technique. And around the world, we can see ChatGPT talk about even you can generate a website. There are many solutions that we can use today to create very, very great content by having a very simple prompt and having AI to take that. And I think for all of you that are in the enterprise today, it's a great market opportunity because as a trajectory, we can see, we will see this will be a very big growth for many of your business. But as a developer, we have a lot of pain points, right? Because this is a very new technology. And I think for me, from a background, I did GPU programming and I did CPU programming. I paralyzed on everything, including FPGA. One thing I really care about is really about the efficiency, right? How, is it cost effective to run such thing? So today, that's why I want to bring Paula in, because Paula going to tell us some of the really hard problem we're trying to solve at Intel and making these possible. Paula, would you like to tell us what's so hard about generative AI and why people are struggling to run it on some of the, let's say, on the edge, maybe on the cloud as well. So what do we need to do to get there?
Yes, Raymond, you are totally right. We have a lot of pains in generative AI. We have a great tool that we can utilize pretty well, but you can see these kind of pains. I think that maybe developers in the audience could identify that. So we have large model size, so in between 1 GB and 8 GB. This is too much. We have a large memory footprint. That means that when you run the model, all of the RAM of your computer is consumed. And also another thing is the slow inference speed. I'm not the person to be in front of one computer waiting for 5 minutes, 10 minutes, the result. And we can see that with generative AI, unfortunately. So these models, we have artificial intelligence technique combining on those models. And those models are difficult for training and also for optimizing. And for sure, we have no flexibility to run workloads on different hardware. So those things we can see that we can see as a pain points in generative AI. Today, we'll be focused in one single example, that is Stable Diffusion, text to image, when you need to use a text prompt and you can see a result. Basically here, you generate an image from a noise vector in multiple small steps, refining the noise to a latent image representation. So it sounds a little bit complicated, but using the models, we can see this working. The training process of this model is based on adding random noise to training data. And the inference part is just reversing the noising to reconstruct data samples. It sounds really easy, but it takes a lot of time. And that means that this generative AI and also another ones increases the overall inference time. That means that we have high inference time, but also poor customer experience. Personally, I won't be happy with that. So the point here is, what is the solution? So maybe we need to think about putting the table which solutions we have for developers. So the first solution that maybe I have in mind is to use powerful machines as a data center, But also another solution is use edge device or also your laptop. So we can see how this is possible today, the two approaches. And we can see how we can, coming from these pain points, how we can switch or we can flip these pain points in a solution and make generative AI easier with OpenVINO. So instead to have a large model size, we can reduce the model size, we can reduce the memory footprint, we can run the inference faster, we could have a strategy for optimization and also have the flexibility to run these workloads in different Intel hardware. So, and I think that this is the moment to show the demo. I'm pretty excited because, demo moment is the reality. It's risky. This is a live demo. I love this kind of thing. So let me share my screen and we will see the demo in shortly. So in this demo, we will show you 3 different approaches. So let me first go with this. So 3 different approaches. We will have a native PyTorch model running in CPU. We will have OpenVINO model running also in the same CPU. And also we will have FP16 precision OpenVINO model running an Intel discrete GPU. And you will be so excited with the result.
And a lot of people ask today is like, do we only show this today? Yes, we have text to image, but at the end, we're going to show you a couple more examples beyond this, okay? So hold your horses, everyone. Let's take a look what Paula have today.
Wow. Thank you, Raymond. That is great. So, okay, let's see what I have here in this machine. So I have here in this machine a Xeon server with a data center GPU Flex. It's a discrete GPU. The first example that we can see is the PyTorch model, the native PyTorch model running in this CPU. And as you see here, it took 33 seconds with 17 steps. That is not bad. It's not the 5 minutes that I saw before. It's okay. This is great. When I convert the model to OpenVINO, and we have here the result. I have the text prompt like a red car in a snowy forest. That is good. And here we have the OpenVINO approach And let's see, we have here the OpenVINO approach with 18 seconds. 18 seconds is almost 2x faster, Raymond.
Yeah, that's the runtime. So we didn't have to do a lot of
This,
work. Just run it on OpenVINO runtime. You get the speed up. That's right. That's good.
this is great because we have here the OpenVINO model, the intermediate representation format, and also the runtime is utilized by this function here, OB Stable Diffusion pipeline. I will explain this later today. But this is
one
good,
thing
2x
is,
faster.
these are all the code to run Stable Diffusion today with OpenVINO. Am I right?
Yes, so
What
we
I
have
see
the
on the
6
screen
lines
here.
of code.
Yeah.
6 lines of code. So we are downloading the model from the Hugging Face Hub, utilizing Optimum Intel with OpenVINO, that is OB Stable Diffusion pipeline. And then we are just saving this model and just compiling the model into the CPU.
Yeah.
And do you want to see something very exciting, Raymond?
I'm excited. Can we go better? Can we go faster?
Yes, right now we have 2x. Do you want more?
Right, we want more.
Let's see. Let's see the next result. Is using also the full precision model in the DGPU with the same function OB Stable Diffusion pipeline. So in that case, we have, can you read this number, Raymond, for me?
It's 1 or 1.5. I think that's around it. 1.
1
that's
second.
Pretty fast.
1 second.
I think it's I don't know. It's pretty impressive speed.
Yes, it's 1 second. So we are running the full precision model, and we are making the conversion. OpenVINO is making the conversion to FP16 on the fly and running in the DGPU just in 1 second. I want to show you, and also to the audience today, how this is working. It's
Okay,
1 second in front of your eyes.
So this is live. So
this is
how
live,
about change the prom a little bit? Let's make it like
more risky.
The second one. I want to see what you can do there.
Okay, right. Let me see. So I don't know if this is working. This is the first.
Yeah.
Oh, okay. Good.
Oh my God, that's
1
Coco.
second. This is Coco. This is the Ryan's dog.
Yeah. If you scroll down, let's see the full dog, if you don't mind. That's pretty quick. I think that that couple line of code can do Stable Diffusion it's interesting because I remember going through a lot of source code. A lot of them are very complicated and hard to use. This is almost close to like a library call, just a couple line of code. All right, but of course, this is like a server, right? Can we do better on people? Let's say I have a laptop today. I have a discrete graphics card. Let's say Intel Arc. Can we do the same?
Yes, we can do the same. So I'm switching to one machine that I have here. I have a Intel Core with a Arc 770. So you can see my machine here, the information of my machine here. So, and we can run this demo also using this Arc A770, a gaming discrete GPU. And that is a surprise, we can use also AI on this card.
I think this is worth talking about because we have iGPU, we have CPU, we also have the DGPU. For the audience, actually, if you have any of this, you can run the same code because we support all of these hardware with OpenVINO. I think that's almost to a surprise. Like anything that's Intel can run, compute can do OpenVINO today is a great support. Let's keep going.
We are using exactly the same model that I showed you before, exactly the same. And I will run this in the discrete GPU. And let's try another one. I will show you something cool here. Let's try this one. Let's try another one. And I will show you this image. It's creating every second. We can create a new image.
So you're running in a loop right now, basically.
Yes, I'm running this in the loop. And you can see how this is generating in 1 second.
Now we can have a gallery just doing this right now on your gaming PC. So this is really nice because I think to a lot of us may be surprised. Intel Arc is actually capable of running a lot of AI workload as well. Originally it was designed for gaming, of course, as a gaming graphics card. But today we can also utilize it for solving a lot of AI problems. I think this is a very important step moving forward. I think for all of us, we're very happy about it. That's really cool. Paula, thanks for the demo. But how does it work? We gotta see how.
Yes, that's the questions. That is the
Right.
question. So I think the next thing that I want to explain you is what is happening behind the scenes. This is, I'm so excited to see 1 second in the GPU how this is possible. And this is possible because we have multiple systems here, but basically the cornerstone of these is OpenVINO runtime. So we can accelerate these models with Intel hardware because we have this toolkit. So let me continue with the deck, and I will explain you something. So here you can see the code that I can use. You running diffusers with Hugging Face in red. I have these lines, and I have the Stable Diffusion pipeline there. I just make a change to OB Stable Diffusion pipeline class to use Optimum Intel with OpenVINO. And this is the same code that I use in the notebooks, exactly the same. So the only thing that I changed is that I needed to just define the device. That's all. It's just 6 lines of code to run a Stable Diffusion. And I really want to explain you something that maybe we need to, contextualize the audience. Maybe you are not super familiar with Hugging Face and on all. So first of all, we need to define 4 things, Raymond, here. We need to define what is Hugging Face. Hugging Face
Right.
Hub is a platform where you have models, data sets. You have also demo apps.
Yeah.
In Hugging Face, there are 2 libraries. One library is transformers and another library is diffusers. So those libraries provide a simple method to deploy many trending generative AI models. It can provide APIs to download these pre-trained models, and you can use those models super easy. And the third though is we have Optimum Intel. We have Optimum Intel is an interface between transformers and diffusers and tools and libraries provided by Intel to accelerate the end-to-end pipelines on Intel hardware. And the 4th element is that as one of the backends of Optimum Intel, OpenVINO is triggering transformers and diffusers deployment with minimum code modifications. As you see here, just 6 lines of code, and we can run this faster. We can run this faster on Intel hardware.
So there are 2 things I think I learned here. One is that you have the pipe to device name. So I saw that's how you do from CPU to GPU. Am I right? That's like a very important line there. And then the other one I see is by switching to this, now you're running on the OpenVINO runtime instead of running it on the native way. I don't know exactly how it works behind the scene there, but I see this way you can now using the OpenVINO runtime to execute the code. I think that's very intriguing because I thought I had to do a lot of work to get it done, but now this is pretty straightforward coding. That's good.
Let me explain you. This is the next thing that I want to do is explain you how this OB Stable Diffusion pipeline function is working. Because for sure we have OpenVINO runtime running there. So that will be amazing to understand what is happening under the hood. So, but first, before to go to that topic, I really want to explain what OpenVINO is, because maybe people in the audience, you don't know what OpenVINO is. So OpenVINO stands for Open Source Visual Inference Neural Network Optimization. And OpenVINO was created in 2017 as a toolkit for optimizing and run the inference with computer vision models mainly. But over these 5 years, also we have involved another kind of AI models as natural language processing, audio, text processing, and now we are working also with generative AI. And I'm so excited to invite to the webinar, to be on camera, Ryan, who can tell us more about what is OpenVINO and how OpenVINO is working on this integration with different kind of Intel hardware. Ryan, floor is yours.
Thanks, Paula. So as you'll see on the next slide, OpenVINO at a high level, we're taking models that are trained in deep learning frameworks like PyTorch, TensorFlow, and then we're optimizing them to run on all of this different Intel hardware and also some third-party hardware like ARM. So you saw a demo with a generative model like Stable Diffusion. Of course, there's many others that we support. and that you can optimize with our tools. And when we say optimize, we're talking about doing compression of the models, converting it to the optimal precision for the device. So like with GPU, we were showing you can easily use FP16, which will reduce the model size significantly and also improve the performance on Intel integrated GPUs and discrete GPUs. And then there's also tools for quantization where training, post-training quantization, distillation, sparsity. There's a whole set of different ways you can prune the model using our tools like the neural network compression framework, which is part of OpenVINO Toolkit. And the great thing that I love is that you can run cross-platform. So Paula showed running on Ubuntu using Linux. We support different versions of Linux, but also Windows. So natively, we support Windows, which is great. You don't need WSL. You can just use Windows directly, whether you're in Python, C++, C. We also have model serving. So really across the board, we can support serving or integrating directly into applications. And OpenVINO as a runtime is integrated into, you saw Hugging Face Optimum, which is a library from Hugging Face, but also Ultralytics. If you've heard of YOLO v5 and YOLO v8, that we're integrated into that ecosystem as well. Onyx runtime, you can use OpenVINO if you're already in Onyx runtime. And then of course, we would love for you to adopt OpenVINO natively and integrate it into your applications. So that's OpenVINO in a nutshell. And thanks, Paula.
No, thank you, Ryan. So I really want to ask you something, Ryan, because I saw your post in LinkedIn. So what is your experience with running a Stable Diffusion with the ARC 770?
Yeah, no, I'm glad that you showed running on the ARC because actually I went and I needed to upgrade my PC at home. So I had an old GPU and I went and bought one of these from Walmart. So if you're in the US, it's really easy to find these. You can just search for ARC A770. I don't know if you can see it on here. Oh,
This is
oops.
this is
Here we go.
16 gigabytes, no?
Yeah, 16 gigabytes. There's a few different partners that are distributing these. This one that I have is from, let's see, which one is it? I think it's the Acer. Yeah, Acer distributed GPU. But if you go to Amazon, Walmart, Best Buy in the United States, and a number of different distributors around the world, you can buy these. I actually just took out my old GPU card and replaced it with an Intel Arc A770, installed the new drivers on Windows, and installed OpenVINO, and I was able to run the same code that Paula was showing, getting really instant performance, 1 to 2 seconds to generate a 512 by 512 image. And I just think it's really cool that we can do that in Windows, no WSL, native support, super fast, and on my PC that with a GPU that's mostly for desktop and gaming usage, it can now be used for AI. So OpenVINO is pretty cool.
Thank you, Ryan. I really appreciate that. So I also have the same demo, the same notebook running in Windows, and Windows is running exactly in the same way. So it's just 1 second. So that is great. I mean, thank you, Ryan. So we will continue, and thanks for this, introduction about OpenVINO. I really want to show next what is the benefits to use OpenVINO runtime with the Stable Diffusion. So let me continue with the flow here. And we were talking about this, how we can make easier this generative AI stuff. So let's see how we can, cover those benefits. The first thing that we will cover today is the strategy optimizing. So here we don't want to talk today about quantization itself. We want to talk about optimization. And the first thing that you saw in the demo is we were downloading these models from the Hugging Face hub. So when we download these models, so we have the text encoder, text encoder to create condition, to create an image from the text prompt. Also, we have the unit model for step-by-step denoising latent image representation. And also we have the autoencoder with the decoder for decoding latent space to an image. And, we have here the native models, and we need to move to the OpenVINO format. And to move to the OpenVINO format, the first step is the conversion. So in the conversion, we need to convert to Onyx first, and we need to then we need to save the OpenVINO format. I really want to talk about what happened here in the conversion. In the conversion, if you are using the Intel DGPU, discrete GPU, you don't need to make the conversion to FP16 because OpenVINO is taking care of making this conversion on the fly when you compile the model to the device. Here we are making the conversion to the full precision model in the native PyTorch model to the OpenVINO format. But when we compile this model to the specific device, in this case, we were talking about DGPU, discrete GPU, for running this in 1 second, OpenVINO is making the conversion on the fly. And that is great. So we have here the text encoder, the unit model, and the decoder. So then you saw this function. This function was OB Stable Diffusion pipeline. So we have here the inference pipeline where we have the models that I was talking before, and also another elements as the tokenizer and also the scheduler. As an input, we need to have the text prompt, the negative prompt, and also input C. And this information through this function, we will see the output image. And I know you are familiar with this. You can see this OB Stable Diffusion pipeline class in Hugging Face, Optimum Intel, and also in the notebooks that we have in OpenVINO Notebooks repository. So here is an example of how we need to run this OB Stable Diffusion pipeline. So, at the end, this is the simplicity that we have in this OB Stable Diffusion pipeline. We have OpenVINO runtime. And for that reason, we can see that improvement in the inference speed, 2x for running OpenVINO model in CPU with OpenVINO runtime, and 1 second, 30x in comparison with the native model in CPU with the discrete GPU. And this is an amazing result. And I just want to cover here what is happening with these benefits. So right now we're talking about reduced model size. And the question is, we reduce the model size, yes or not? And the answer is, we are using FP32 native model, and it's 5 gigabytes approx. The FP32 OpenVINO model is the same size. We are not changing the size for the full precision model. But when we change the precision to FP16, we can see a reduction in 50%, 50%. So, and this is a great reduction if you need to save some space in your machine, and this is a good approach. So the next question is, do we see any faster inference speed and flexibility for run these workloads in different hardware? And the answer is yes. So we saw faster inference speed, and we saw the flexibility to run these workloads on different Intel hardware, CPU, and discrete GPU. So next, right now you have a lot of elements. You have Hugging Face Optimum Intel with OpenVINO. You also know about OpenVINO runtime. And with those elements, what kind of things you can do next with generative AI? That is the question. And I really want to invite you to convert, optimize, and run models using OpenVINO and Optimum Intel with OpenVINO. So how you can do that? So I really want to share with you this the notebook that I was showing today. You can scan this QR code, or if you download the slides, you can just click over the QR code and access the same code that I showed today. But if you want to know more about what is happening behind scenes, I want to invite you also to scan this QR code, and here you can find a notebook with more details about, the downloading process, the conversion process, the compilation process, and how we are using OB Stable Diffusion pipeline function. So, but the good thing is that is not all. I also see one question in the Q&A section, that if we talk just about Stable Diffusion today. Yes, so we are talking about this because we wanted to show as an example how OpenVINO runtime could be working with generative AI. But if you are interested to know more about that, we are working in all generative AI trends. in the OpenVINO Notebooks repository, we have a lot of examples. So we have different kind of taste of Stable Diffusion. We have in painting, we have text to image, we have infinite zoom, we have clip, blip, we have deep float, we have dolly, image blind. This is a great approach that you can take a look of that. And I'm just want to close this conversation with you, and I hope that we started with this approach, talking about the pain points in generative AI, and we show you how you can flip this to make generative AI easier with OpenVINO. And today we talk about how you can reduce the model size, how you can run the inference faster, how you can create an optimization with your models, and have the flexibility to run your models in different hardware. But maybe we are missing something here, is the reduction in the memory footprint. But this is something that we want to have for the next month, in the next webinar, in the next workshop, where my teammates, Adrian and Shuo, will show you the importance of quantization in deep learning. So don't miss that the workshop. That will be amazing for you. You can learn more about how you can reduce the memory footprint in your edge devices. So I really appreciate your time. So thank you so much for staying with us. Please connect with me at the end of the presentation. You will see my LinkedIn profile. So I'm really happy to answer your questions offline. And thanks for your attention.
Well, you're not going anywhere yet, Paula. We do have a lot of questions on the left side. I would like to have your some of your thinking behind it. So I think one of the questions people ask already is, how can we even go faster on CPU? Do we use quantization? Yes, that's why we have this next webinar to explain how it works, what we have done to make it like efficient running on CPU. But when we do quantization, it also provides benefit on our GPUs, etc. So please join the next one, then we'll answer more of that question for everyone. I think there's a question people ask, like, this is an interesting one too. Does OpenVINO provide training and inference capability? So do we do training as well? How do we position there?
Okay, for generative AI, we don't have any tool yet, but we have another kind of tools that OpenVINO has for classic training. We have transfer learning with different kind of tools as Anomaly or OpenVINO training extensions. So we are touching the training part with transfer learning with these tools, Anomaly and OpenVINO training extensions.
And that's right. One is called the OpenVINO training extension. I think we also have Getty, right? But it's not directly about generative AI, but I think for people who love to learn about how we do end-to-end from training to deployment, we do have another product called Getty. And then very interestingly, Paula is also evangelist from Getty. So if you have any questions about the training, you can definitely go.
Let me talk about a little bit about Intel Getty. So if you want to deploy rapidly, computer vision models, you can use Getty. So you can cover the full collaboration of your team, have you there, data scientists, developers, subject matter experts, and with a few images, you can start the training process. I think that it is not because I'm the Getty evangelist, it's because I love the platform, and I think that this is a great approach that Intel is making right now.
And then to answer the question again, OpenVINO is not for training. So OpenVINO is for inference, but we have another tool for training if interest. And then feel free to talk to us if you want to hear more about how the other frameworks works together with OpenVINO. Again, OpenVINO is for deployment and fast. Now, the next question I see here is, they say, okay, you have a very high-end GPU, you have a very high-end CPU. What if I have a regular NUX, have a CPU and GPU combo, the IGP combo? Does it work? And yeah.
I have here a NUC. It's a regular combo, and that is working pretty well. So I have a NUC with 12th gen Intel Core and also a ARC 770 built in the processor, and it's working exactly the same. So this is a great approach.
Okay, so we just work with the iGPU. Well, this is also an important question is, how does OpenVINO work with other frameworks So we have PyTorch, we have TensorFlow. Well, now we have all this new framework that's coming up. So, like, what's the connection between OpenVINO and the frameworks today? And then yeah.
So OpenVINO is agnostic to the frameworks. We
Okay.
have OpenVINO could receive different kind of frameworks: PyTorch, TensorFlow, Keras, Caffe, and more, as Ryan mentioned that before. And just making the conversion so we can run the optimization part and also run the quantization after that. Something that is great is that if you want to optimize the model, you can make like a simple pipeline, just making the conversion to the model. You can get the optimization. If you want to make the quantization, you can also make that like a post-training quantization. Or if you are working with PyTorch and TensorFlow and Onyx, you can run quantization aware training. And this is it is an amazing topic. I think that Adrian and Joe will show that in 1 month.
Right. Well, I think this perfect time now we bring Ryan and the rest of the team to answer some of this question. Because Ryan, Ria, are you here? We have a lot of questions for all of you. And this is for Ryan, actually, because this is about the product itself, about OpenVINO. So a lot of people wonder about the support, right? From, let's say, does it work with Chrome OS, ARM? Like, what is the beyond the traditional Linux and Windows? What else we support in OpenVINO?
Yeah, so I'll take the ARM part first. So starting in the 2023 release of OpenVINO that came out a few weeks ago, we started officially supporting ARM devices. We're currently only testing and supporting the Apple M1, M2, and the Raspberry Pi devices, but we're going to expand that. And so we have packages that you can download if you're on developing on a MacBook and you want to pip install OpenVINO. It's really easy to do that, and you can install OpenVINO and run it without having to build from source. And then if you're using other devices, you can OpenVINO is completely open source. There's a few plugins that are for specialized hardware that are not open source, but the CPU, GPU plugins are completely open, and the tools that you use. So if you want to build a binary that you can run on different flavors of Linux, like you can do that by building from source. You can go to OpenVINO Toolkit on GitHub, and you'll see the OpenVINO repo. That's to build the OpenVINO runtime and developer tools. So we make it pretty simple for the community. If you really want to try running this on a different device, you can do that. And the ARM support is somewhat limited today. When I say limited, it's because we're currently supporting FP32 on ARM CPU devices using our CPU plugin. And we're expanding that to FP16 and Int8 in the future. So that's under active development. So if that's something that you're interested in, please open an issue on GitHub. Let us know that that's something that you'd like us to do, and maybe tell us which models you're looking at so we can try to optimize those first. But yeah, we'll have in the 2023.1 and 2023.2 release, watch the release notes. We're going to have some expanded support for ARM devices.
Perfect. And then I have a question for Ria. Are you ready, Ria? So people
I'm
asked
ready.
about the source code. Actually, I think you've done some of the development of the source code that we're showing today. So they asked the question is I guess native stable diffusion model is not in Bean and XML, which is the IR format right now. So where did that happen? Where's the conversion happen? When, at which step of that happened? Maybe we can look at the source code quickly and tell the audience.
Yeah, so if you're looking at the native OpenVINO demo, and you can find this, and I've been sharing the links in the chat via OpenVINO Notebooks, we're actually doing the conversion as part of a step that you can see as part of that notebook. Now with Optimum, what's going on is we're actually loading models from Hugging Face and then using OpenVINO OpenVINO runtime in order to run them. So here you can see the import on the screen here that's importing OV Stable Diffusion pipeline that's using OpenVINO as the backend for running the models.
Okay, so right here, the compile, is it the part that it does some of the conversion?
Yes, exactly.
Code? Okay.
Yeah.
All right. So now you know where it is. Now there's any question I think everyone can answer. I'll put it on Ria first. Is there any difference with SD, which is Stable Diffusion 2.1, or could we see similar performance on Stable Diffusion 1.5, etc.? Is the notebook 225 is superseded by 236, which is the secret code of the notebooks. But like, so what's going on here? Just tell us maybe a little bit more. Where's the latest and greatest? I think that's what people want to know.
Right. Okay. So that's a fantastic question. And again, as part of the notebooks, we also have a very detailed kind of description of what's different between Stable Diffusions version 2.1 and going on, and then, the previous versions as well. So notably resolution, size, quality, and a number of different elements that have changed. So you can definitely expect similar performance, but that would depend on your setup. So I would say that definitely if you're interested, try it on your setup, depending on what hardware you have available to do a comparison. But notably, the latest version of Stable Diffusion definitely has some really great improvements for even more better quality art.
Okay, so
and Raymond, I think Paula had actually tested switching out. You can just switch out stability like the 2.1, switch it out for 1.5. Yeah. What were the results that you saw, Paula?
The performance is the same, exactly the same, 1 second with two models. So we can also switch and change the image size, change for sure the number of seats, so the steps, and we will see exactly the same performance. We don't see differences in between that, and that is good, running also in the DGPU and CPU.
Nice.
Okay, so this is really good. I think I gotta wrap it up with 2 more questions, and then if any more questions, you can ask us like anytime on LinkedIn or with our channel. So now this one is interesting. So someone want to learn more about beyond Stable Diffusion, which is the next one people want to try as well. I heard about Dolly, right? Where's the Dolly? Like, where can we find about Dolly? Because people are interested in the test generation as well. So what things we actually have there in the repository?
Yes, I think that this is awesome to something that they can try, and they can scan this QR code. And we have different kind of generative AI trends there. So the team has been working so hard to be on the state of the art of the generative AI models. So we have their Dolly V2 for sure, and they can run this in a easy way, installing OpenVINO notebooks. They can, if they haven't tried before OpenVINO Notebooks repository, that is great. They will find a lot of examples there, more than maybe 80 examples we have there. And we are in the state of the art. I will say that we are in the state of the art of the generative AI models.
Okay, so for everyone, we also have BERT. We also have GPT-2 and 3, I think, in the repository. So there's a lot of good ones that I think people forgot about BERT already. BERT
Music generation. There's like the free VC using Wave LM. There's a lot of really interesting ones that you can check out, and we'll have some new ones coming soon, like code generation that you can run on your laptop. So definitely bookmark it and try out the notebooks repo.
Right. So we have all the good up there. One last question. I think this will be the last one because we gotta be at the top of the hour now. So this is like a big question. It's like you show 2 hardware. One is the Intel Arc. One is the Flex, the data center GPU. What's the difference between those 2? I think maybe Ryan can help answer this one. It's a bit of
I can give like a high level description, and Ria answered in the chat too, and I'll let her elaborate. But my simple answer is that the data center Flex GPUs are designed to go into like a server chassis that would go in a data center where you're racking several servers, maybe putting 4 to 8 PCIe cards into the same server. So they have different power requirements in terms of stability, in terms of heat, because you're going to be packing them into a server. Where the Arc is meant for a desktop or a laptop, you typically have just one PCIe card that you connect to the power supply in the desktop, or that's integrated into the laptop by the manufacturer. So that's kind of the difference between the cards. The Arc card is you can order it like I did from Walmart. I paid like a little over $385 before tax and shipping. So it's definitely more accessible to developers, but it's also not intended to go in a server. So if you're building out a cluster of GPUs, you're going to want to use the data center rated ones. If you have an industrial application, you probably want the data center rated one. But if you're installing it in your PC or laptop, you're going to go with the Arc. And maybe if Ria has any more to add.
Oh, I think you totally covered it, Ryan. The compare and contrast between them. If you're a developer looking maybe to get started right away with your setup, then maybe go for the ARC 770. But as Ryan shared, if you're looking for a more, data center type of setup, then the Flex 170 is definitely a very good option. So.
Good. I think, well, thank you again answering a lot of these great questions and from the audience. Again, I think now is the time for you all to really try it and install it. So for a lot of you that using Ubuntu, Red Hat, or any sort of these kind of like different deployment system, you can try it today and scan this QR code and look at the documentation a little bit, or you can just pip install and give it a try. So a couple call out for other things you can try from Intel, because today we talk about generative AI, but definitely follow our blogs and hear more what we've been working on behind the scene, because Paula, Ryan, Ria, we're publishing blog on Medium that you'll see the latest and greatest beyond this webinar. And beyond that, okay, developer cloud. So people ask like, how can I run this on some of the Intel hardware? If you don't have, let's say, the Intel hardware that you need today, you want to give it a try, you can go on developer cloud and then, brand out the hardware and see how it feel like, or like try it out. And that's one way to get yourself, really into the ecosystem with the, try before you buy it, right? And some of the example here today, we can also try it on the developer cloud, on dev cloud, on the edge. Again, depending on what you're running on, because let's say you're running on the Xeon with less core, so the performance may vary. But that's also a way for you to gauge what performance you need to deploy your system. So that's like a great way for you to learn what it takes to deploy. The next one, again, is Getty, right? So if anyone have questions about how you can also bring computer vision system in production, and Getty and Paula will be your go-to today. And least and not last, I think everyone should talk to Ryan, talk to Ria. You can find us on LinkedIn. But this is a two from Paula and I. Again, ask any questions. Feedback is always welcome. But if you have even harder questions, we have Intel forums, so you can ask questions there. And that's many ways you can engage with us. But definitely come talk to us.